Hi all, welcome to Heights to Fly. Today we are discussing what is an invertible function. Invertible functions in relations and functions. Okay. Before going to invertible functions, let's discuss what is composition of functions. We can represent composition of two functions g of x and f of x as g composition f of x. G composition f of x. This is a representation of composition. We can represent it as g of f of x for all x element of a set A. Okay, this is the representation for composition of functions. In previous class, we discussed about composition of functions and its related problems. Let's go to what is an invertible function. A function is said to be, a function f is said to be invertible, is said to be invertible. A function f which is from x to y is said to be invertible if there is another function, if there exists another function g from y to x, here x to y, here y to x, such that the condition is g composition f is equal to I of x ix and f composition g is equal to iy. This is the identity function on x, identity function on x, and this is identity function on y. Then the function g is called inverse of function f. If the condition is satisfied, then we can call g as the inverse of function f. Okay, and g can be represented as is denoted by f inverse. Okay, what have we discussed? We can represent an inverse of the function f as f inverse. Here it is g. What is the condition? If f is a function from x to y, then there exists a function g y to x such that g composition f is equal to ix and f composition g is equal to iy. Then what are the conditions to be followed? What are the conditions to be followed if there is a inverse of function existing? If f is invertible, then f must be 1 to 1 and 1 to. We know what is 1 to 1 and 1 to. If f is invertible, then f must be have the property 1 to 1 and 1 to. 1 to 1 means xy, x1, y1, like that. 1 to means all the codomain values should exist in the range. If we will discuss what is 1 to 1 and 1 to 1 next example. In other words, we can redefine this as if f is 1 to 1 and 1 to, then f must be invertible. Okay, that is, if there is a function is said to be invertible, there it should be 1 to 1 and 1 to, or if a function is 1 to 1 and 1 to, then we can say that it is invertible also. Okay, let's go to an example. First, consider a set S is equal to 1, 2, 3. The question is determine whether the function f It is defined from S to F, S to S, defined as below, have inverse. Find F inverse if F inverse exists. Okay, we have given a set answer. That's a function is defined. We have to find whether F inverse exists, and if exists, what is the value of F. First set is F is equal to set 1, 1, 2, 3, 3, 3. What is the function? What is the property of a invertible function? 1, 1 and onto. Check whether it is a 1, 1 and onto. Here the set is 2, 2. Here the set is 2, 2. Let's take the property 1, 1. This is 1, 1 because for each x value there is a single y value. 1 maps to 1, 2, 2, 2, 3 to 3. So we can say that it is a following 1, 1 property. What about onto? Onto means each range value, all the range should contain all the values in the set or the codomain. 1, 2, 3. 1, 2, 3 is the range value here. So it also follows the onto property. So we can say that F is invertible. F is invertible. We can invert F inverse is equal to reverse. 1, 1, 2, 2, 3, 3. Okay. Next set is F is equal to 1, 2, 2, 1 and 3, 1. Let's check the 1 to 1 property. Is it 1 to 1? 1, 2, 2, 1, 3, 1. That is 2 and 3 have same image. 2 and 3 have 2, 3 have same image, which is 1. So it don't have a 1 to 1 property. 1 to 1 property is not followed. 1 to 1 property is not followed. Okay, so it is not, first case itself it is not following. Onto is also not following because in the range value 3 is not present. 3 is not present, so it is not onto also. So F inverse, F is not invertible. So F inverse does not exist. And the third case, 1, 3, 3, 2 and 2, 1. Okay, what about 1 to 1 property? 1 to 1 property, 1, 3. 3 have image 2 and 2. So each x value have a different y value. So we can say that 1 to 1 property is following. Then what about onto? Onto. The range is 3, 2, 1. All the elements in the codomain set are existing. So it is also onto. So F is invertible. F is invertible. What is the F inverse? F inverse is equal to reverse. 3, 1, 2, 3 and 2, 1. Hope you understand. Simple question, how to understand a function is invertible and how to find out the invertible function. Let's go to another example. Consider a function which is defined from a set n to y. N to y. F of x is equal to 4x plus 3. F of x is equal to 4x plus 3. And y is equal to y element of n, y is defined as 4x plus 3, x element of n, show that f is invertible. So this is the property, this one, and f, show that f is invertible. Okay, let's go to the solution. Here even let's consider y element of capital Y, y element of capital Y. We can redefine y as, what is the value of y? Y is equal to 4x plus 3. So we can write y is equal to 4x plus 3. Okay. Let's rewrite the value of x using this equation. Rewrite the value of x using this equation. Then y minus 3 divided by 4. Hope you understand. Y minus 3 divided by 4. We redefine the value x using the equation. Okay, this is a function f. This is relating to the function f. Let's go to the invertible function g. Reverse of function g, f. Okay, then what will be g? G will be defined from y to n. Y to n. So we can define it as y to n. Then we can define g of y as what we get here, y minus 3 divided by 4. Y minus 3 divided by 4. Okay, let's find decomposition f of x. G of y we get it from here, y minus 3 divided by 4, g of y. Okay, decomposition f of x is equal to g of f of x. F of x is equal to 4x plus 3. F of x is equal to 4x plus 3. So g of 4x plus 3, g of y is equal to y minus 3 divided by. So we have to substitute the y value. We have to substitute the y value with this value. G of y is equal to y minus 3 divided by 4. Y minus 3 divided by 4. Here the y value is 4x plus 3. So we have to substitute this y with this one. So 4x plus 3 minus 3 divided by 4, which is equal to plus 3 minus 3 0. 4x divided by 4, which is equal to x. Okay, it is equal to x. Next, decomposition f of x is equal to x. Next case, f composition g of y, which is equal to f of g of y. G of y is equal to y minus 3 divided by 4. Y minus 3 divided by 4, which is equal to, what is 4x plus 3. F of x is equal to 4x plus 3. So f of x is equal to 4x plus 3. We know that. So here the x value is y minus 3 divided by 4. So we have to substitute this x value here in position of x. So 4 into y minus 3 divided by 4 plus 3. So 4 cancelled, 4 minus 3 plus 3, which is equal to y. Decomposition f of x is equal to x. F composition g of y is equal to y. So we can say that decomposition f is equal to im and f composition g is equal to iy. If we say function from n to y and g is a function from y to m, therefore f is invertible and g is the inverse of f. Okay, g is the inverse of f. Let's go to the next example. Similar pattern is following all types of these questions into how to find an invert. First we define the f function f, then we have to define the function g, that is the reverse function. Then we have to substitute the value of y there, then g composition f and f composition g have to be find out. Okay, consider y element of capital Y. The question is y is equal to n square, n element of n, and the function f is defined from n to y. F of n is equal to n square, f of n is equal to n square. Okay, then n is equal to root y, n is equal to root y is equal to n square, y is equal to n square. Then we can define n is equal to root y. This is for function f. Then go to the function g, which is defined from y to n, reverse of this, y to n. Okay, g of y is equal to root y. Okay, then we have to find g composition f of n. G composition f of n. F of n is equal to n square. So g composition g of f of n, which is equal to g of n square. Here we have to substitute what is g of y, root y. So we have to substitute in place of y n square, which is equal to n. And what is f composition g of y? F of g of y is equal to root y. What is f of x? F of x is equal to n square. So root y square. F of n is equal to n square, and g of y is equal to root y. So we have to substitute g of y here, root y. F of n is the square of this value. So we take the square, which is equal to y. G composition f is equal to in, and f composition g is equal to iy. Therefore f is invertible. F inverse is equal to g. Okay, let's go to the next question. Consider f is a function defined from n to r, and the function f is defined as 4x square plus 12x plus 15. Okay, show that f is defined from n to s. A resist range of f is invertible. Find the inverse of f. Find the inverse of similar question. There is a small change, there is a polynomial is given, and we have to show the range, and this should be invertible. So consider an element, y element of f. Y is equal to 4x square plus 12x plus 15. It is given in the question. Okay, we can rewrite in polynomial. This is a polynomial. We have to rewrite it in the square form. Let's consider it in the form a plus b the whole square. Okay, 2x, and there is a term 4 into 3. If we are 2x plus 3. Okay, if we are considering 3, 2 into 3 here, then there is a 9 only. So there is an extra 6. So 6. You have to convert in a square form. So 2x plus 3. When we are factorizing this, 2x plus 3, we get the factor, but here the 15 is the value. When we are expanding this, it only gets 9. So there is an extra 6. We have to represent it outside. So we can rewrite 2x plus 3 the whole square plus 6. 4x square plus 6. 12x plus 9. Then plus 6. Okay, x is equal to root of, we can rewrite this one because we can't rewrite the value of x using this equation. That is why we followed this format. Here x is spread into terms, so we can't rewrite, so this form is following. X is equal to y minus 6. Sorry, how to rewrite? 2x plus 3 the whole square is equal to y minus 6. 2x plus 3 is equal to root of 5 minus 6. Then 2x is equal to root of 5 minus 6 minus 3. X is equal to root of y minus 6 minus 3 the whole divided by 2. Okay. Then the value of y should be greater than or equal to 6, because if is less than 6 we will get minus value here. Root of minus value is not possible in this situation. Next, go to the function g, which is defined from s to n. Then we can rewrite g of y is equal to root of y minus 6 minus 3 divided by 2, this one. Okay, then what is decomposition? F of x, which is equal to g of f of x, which is equal to g of, what is f of x? 4x square plus 12x plus 15. We rewrite it as g of 2x plus 3 the whole square plus 6. Okay. Next, what is g of y is equal to root of that y value minus 6 minus 3 divided by 2. So root of 2x plus 3 the whole square plus 6. Then what is here? There is another minus 6. This is this value. This value is this value, and there is another minus 6. Then minus 3 the whole divided by 2. Okay. When we simplify this becomes 0. So root of 2x plus 3 the whole square minus 3 divided by 2. Which is 2x plus 3 square, taking square root, minus 3 divided by 2, which is equal to 0. 3 minus 3 0. 2x divided by 2, which is equal to x. So decomposition f of x is equal to x. Okay. Then what is f composition? G of y is equal to f of, what is g of y? Root of y minus 6 minus 3 divided by 2. So what is f of x is equal to 2x plus 6, like that. So we have to substitute the value 2 root of y minus 6 minus 3 divided by 2 plus 3 the whole square plus 6. 2 2x plus 3 the whole square, 2x plus 3 the whole square. So we are substituting 2 into x value here, 2 into x value here plus 3 the whole square plus 6. 2x plus 3 the whole square plus 6. So 2 into, what is x here? This one, plus 3 the whole square. Okay, plus 6, which is equal to root of y minus 6. This 2 are getting cancelled. This 2 getting cancelled. Minus 3 plus 3 the whole square plus 6. Two single bracket x to x plus 3 the whole square. So 2 cancelled. Root of y minus 6 minus 3 plus 3 the whole square. Minus 3 plus 3 cancelled. Root of y minus 6 the whole square plus 6, which is equal to y minus 6 plus 6, which is equal to y. Previous case we get it as x. So we can say that G composition F is equal to In and F composition G is equal to Is. F is invertible with F inverse is equal to G. So what are the techniques following here? First we define F and then we define G using the function F. Then we will find the G composition F of X and we will find F composition G of Y. This is following in all the problems. Let's go to the next question. A function which is defined from n to n and G is defined from also n to n and H is defined from n to r. Another function H. F of x is equal to 2x, G of y is equal to 3y plus 4 and H of z is equal to sin z. Okay, so that H composition G of F and H composition G of composition F are equal. H composition G composition F of X. So we can rewrite it as composition F of X. H of G composition F of X. We can redefine this one G of F of X. We are removing the composition in each steps, which is equal to H of what is F of X? F of X is equal to 2x. Okay. F of x is equal to 2x, G of y is equal to 3y plus 4 and H of z is equal to sin z. Okay. What is G of x is equal to 3y plus 3. So H of, in place of y we have to substitute the 2x. So 3 into 2x plus 4, that is H of 6x plus 4. H of 6x plus 4. Here z is equal to sin z. Here the value of z is equal to 6x plus 4. So sin 6x plus 4. Once again, H composition G of composition F of x. So we are removing the composition functions using brackets. And finally we get F of x as 2x, substituting the value of y in this G of y as 2x. So we get this. And finally we get H of 6x plus 4. So we have to substitute the z using 6x plus 4. So sin 6x plus 4. Then the next portion, H composition G composition F of x, which is equal to H composition G of F of x. So H of composition G of 2x, which is equal to H of G of 2x, which is equal to similar 3x is equal to 2x, the value of x is substituting here, so it becomes 3 into 2x plus 4, which is equal to H of 6x plus 4, which is equal to sin 6x plus 4. So we can say that H composition G composition F is equal to H composition G composition F. The values are same. Okay. So today we discussed a lot about invertible functions. First we define what is an invertible function, and invertible function should follow this condition. So we discussed a problem here. What is an one and on two properties are following by an invertible function. Then how to find show how to whether a function is invertible or not. So what are the basic steps we have to be followed? We have to follow, first we have to define the given function f, then rewrite the value x. Okay, then substitute this value. We have to define the function invertible function g, which is using this definition, and substitute the values. Then we have to find g composition f, and again f composition g. If they are invertible functions, we should get the above specified condition. Okay, thank you for watching. Thank you for watching. Subscribe and share for new videos.